Welcome to Maths Bridge. We train and learn. We shall start learning C programming concepts. Let's get started. In today's agenda, our learning goal would be looking at who is the father of C computer language, concept of algorithm, flowcharts, computer hardware components like a CPU, types of memory, hardware and software, system software, application software, IDEs which we use for building a computer program in C language, my first C program, memory which we use in C program, translation of program, source code compilation, why C programming is called as a procedure oriented programming, features of C programming, applications of C programming. C programming was developed by Dennis Rich at AT&T Bell Laboratory of USA in 1972. He is called as a father of C programming language. C is a general purpose, procedural, imperative computer programming language. Mainly, C programming was developed to develop the Unix operating system. That's an interesting point. It's well suited for business and scientific applications. C programming language is widely used for a system programming, like operating system development. Most of the state-of-the-art softwares have been implemented using C. C is referred to as the foundational language of programming. One of the most widely used term in computer language is an algorithm. We need to understand what is meant by algorithm. An algorithm is a step-by-step procedure to solve a problem. Let's look at an example. Calculate sum of two numbers. What it reminds me, I would be needing two numbers, so I can calculate the sum. My operation would be sum, isn't it? Right? So how would I compute this statement? I need to start the program, and hence I can do my computation. What I would be needing, I needed two numbers. So in step 1, I am saying input number for variable A is what I needed. Input the number, second number in step 2, and then in step 3, since I know the two numbers, I would be computing using mathematical formula sum is equal to A plus B. Then in step 4, I would be displaying sum which I calculated in the previous step. So my goal is achieved. So I can end the program. So few things that you need to understand. You have to start the program at the beginning and you end the program at the last step. In middle, you would be needing two inputs, means like you are reading inputs from the input devices and you are doing a computation as a core object of the program. Once computation done, you would be displaying the final answer on console. Probably in this case, display sum. This is what you're doing. So what I am reminding here is there is a step-by-step procedure which we use to solve this problem, and hence the definition of algorithm is an algorithm is a step-by-step procedure to solve the problem. A set of mathematical instructions are the rules that, especially if given to a computer, will help to calculate an answer to a problem. You agree? Let me reiterate more a precise definition. An algorithm is a finite set of unambiguous instructions which when executed performs a task correctly. How nice it is. Another important word which we heard most frequently in the computer world is flowchart. Just like an algorithm, the flowchart is also a tool to represent a logic. As the name indicates, flowchart helps us graphically visualize the flow of a control within a sequence of statements. You agree? So now the question is, what are the symbols that we are going to use to represent a diagrammatical view of an algorithm? We use these symbols most frequently. This is what we can call it as a terminal symbol, the vowel symbol, which we use for beginning and end of the flowchart. Make a point. This box we call it as a input output box, which we use to represent input operations or output operations. Reading from keyboard, writing, meaning displaying on console. In that context, you would be needing this symbol. This is what we can call it as a process symbol, rectangle symbol, right? This box is used to represent a processing operations. This symbol is used to represent a imperative logic construct. Think of that way. This is what we can call it as a decision box, a diamond shaped symbol, which is used to represent a conditional statement constructs. Each such a box has two exit points. Either it is true or the false. Alright. Based on the condition, the flow will change. The circle symbol is what we see as a connector. Right? So within the same page, intra page, we will use this symbol for connection of the flow. This symbol is used to transfer the flow of control from one point to another within same page. Connector is usually labeled to match with its counterpart. Let's say arrow lines. These are used to show the sequence of flow from one box to another box. Let me reiterate. Flowchart is a diagrammatic representation of the solution for a given problem. The rules of the flowchart, when you're writing a flowchart representation, means when you're drawing a flowchart, you should always think of your flow either from the left to right or top to bottom. Alright. Algorithm versus flowchart. We are trying to map our sequential step-by-step procedure which we built for computing a given problem statement into pictorial representation is known as a flowchart. In this example, I built 6 step-by-step statements to compute my problem statement, isn't it? So I would be needing 6 symbols to represent in my flowchart. Let's look at step 0 to start the program and then step 5 to end the program. Would be needing same symbol, and hence I'm using start and end symbols in my flowchart. In step 1 and step 2, I would be reading number from the input, and hence I would be representing step 1 and 2 using input operation box. Similarly, in step 5, I am displaying calculated output on the console. Let's say I would be needing output operation box. In step 3, I'm computing using mathematical operations, which is where I'm using a rectangle like a symbol which is also known as a process box. All these boxes are now connecting using arrows, which basically tells me a flow of control from start to end. This is how you would be representing your step-by-step sequential steps within your procedure into flowchart. You can build procedures for any problem which you are going to solve, and similarly you can also build flowcharts for that specific algorithm as well. If you practice, you will be able to do it. It's not hard. We are using a computer to solve a problem by building an algorithms, flowcharts, things like that, right? So it is a minimum for us to understand a basic concept of a computer, because we are leveraging a computer to solve our problems. Things like computer has a CPU and then memory, and then computer hardware is connecting with like a input devices and output devices. Input devices, for instance, a keyboard. Output device is probably a display, isn't it, right? CPU. CPU means a central processing unit, which is a core component in your computer. At abstract level, CPU has a control unit, ALU, arithmetic logic unit, and then main memory. This CPU interacting with input devices, output devices, other external peripherals. You must have heard memory very frequently in computer world. Computer memory is just like a human brain. Do you agree? It is used to store data or information and instructions. It is a data storage unit, right? So it is essential for us to understand what are the types of memories which are available in computer world while designing any hardware. Primarily, memories are divided into three high-level categories: cache memory, primary memory, secondary memory. Cache memory means a temporary storage area which is readily available to the processor, meaning which is nearer to the CPU. Under primary category, we have a RAM, ROM. RAM stands for random access memory. ROM stands for read-only memory. Under RAM, we have a static RAM, dynamic RAM. Under ROM, we have a PROM, EPROM, E square PROM. PROM means programmable read-only memory. EPROM means erasable programmable read-only memory. E square PROM means electrically erasable programmable read-only memory. We have also flash under ROM. In secondary memory, we widely used devices like a hard disk. We have few more. So these are variety of memories which we use in hardware design in today's computer world. Precisely in embedded systems, you end up seeing them all, one way or other, in your system. So it is essential for you to understand each type of memory and then its uses. By now we know what is meant by hardware, what is meant by software, isn't it? Hardware in the sense of a physical component of a computer like a CPU, hard disk, input devices, output devices. Software is a program that runs on a computer, right? And then CPU is most important hardware component. It is used to process the data and instructions to control the rest of the computer. We would be also seeing hardware, operating system, some of the applications which runs on the operating system is known as a application software. Types of softwares. Softwares primarily divide into two types, a system software and application software. Let's look at this diagram. The system software, which is very near to hardware, which runs directly on hardware, and application software which runs on top of the system software. There is no direct connection between the application software and hardware. Make a point. And user like we are interacting with the system through the application software. That is how you have to abstract yourself hardware, system software, application software, how user are interacting with your system altogether. Let me reiterate. System software that closely interacting with hardware. Interface between application software and hardware is the system software. Low-level languages are used to write a system software. System software maintains hardware resources. System software is needed to run the system. Considered as a general purpose software for a special purpose hardware is known as a system software. A functions of system software is memory management, process management, file management, security, error detection, scheduling. These are the key concepts which we learn more in operating system concepts. Application software. Application software is a type of software that is mainly developed to perform a specific task as per the user request. It acts as an interface between end user and a system software. For instance, Microsoft Excel, Microsoft Word, Microsoft PowerPoint are the application softwares which runs on system software. In this context, operating system is a system software. Microsoft tools are the application softwares. User like we are the people who are using the application software. Alright. Where would I need to write a programs? Precisely to C programs, to write and compile and see the output. We'd be needing IDEs. IDE means Integrated Development Environment. IDE is a software application that helps programmers efficiently can develop a software code. It helps in software editing, building, testing, debugging, packaging. It is very much advised a software developers to use IDEs to make their job easier. We have many IDEs available which we can use for writing a C programs. All C compilers, C++ compilers can be leveraged for writing your C programs. I would be using dev C++ IDE for writing my C programming. You would be using your own interest of IDE. Alright. My first C program, hello world. Let's try understand basic programming structure of C program. If you look at my screen, I have a sample program to print hello world on the console. These are the line numbers of my program. Line number 1 and 2, I have a header files included for my program. stdio.h, stdlib.h. These are header files. We also known them as a preprocessor directives. Line number 3, I have a blank line. As usual, C ignores white spaces. For the readability point of view, you can have white spaces, whatever you would like to see your program neatly. Line number 4, a function that always appears in C program is int main. Code written inside the curly brackets, right? That is an executable code. In line number 5, printf is a function, library function, which I borrowed from these header definitions. The reason for using them is to display message on the console, output message. Return 0 at line number 6 is a last statement inside the main function. And line number 7, I have a closing curly bracket. This indicates my program ends, end of main function. This is a basic structure of C programming. If I'm able to compile the code, I would get output as a hello world on my console, which is what I expected to see, isn't it? Wow! I completed my first program and also understanding basic structure which I can see in my programming. Memory in C programming. This is a typical memory layout which we use in C programming. Look at how many segments we have. We have a code segment, we have a data segment, we have segment for initialized data, we have a segment for uninitialized data, which are part of your static memory layout section. We also reserve some memory for command line arguments and environmental variables. We have a dynamic memory layout concept, which we use for stacks and heaps. All the static variable are global variables for which the variables which is already initialized during the program development, those are called initialized data, would go and actually sit in this .data segment section. We have the variables not yet been initialized, named as uninitialized data variables, which resides in .bss section. By default, initialized to 0 by exec. Alright, this is the a memory layout which we need to understand while writing a C programming. This architecture is widely important concept in embedded system design. Be with me to understand how this piece of program uses a memory layout in C programming. If you look at this program, we have a global variables. So you would be leveraging either uninitialized data section or initialized data section. Agree? The variable at line number 4 is not yet been initialized. So this would go and sit in uninitialized data section .bss section. Whereas line number 5, I have a initialized global variable. So which would go into initialized data section .data section. Let's coming into main program. Within the main, I have two local variables. One variable named as a local, another one is a pointer variable. These two variables uses a stack memory. In line number 10, dynamically I am allocating a memory. For a dynamic memory allocation, what we use is a heap memory. That is how your memory layout should be understand how your program uses the memory layout, and then you also need to understand how much memory would be needed for writing your complex algorithms. If you don't have enough memory in your system as per the layout designed, then you would be able to understand the requirement and then configure accordingly. This is very important essential concept while writing an embedded programs. Translation of C programming language. In our previous example, we have a sample program is known as a C file, .c file, which uses few .h files. These two would be input to your preprocessor. What preprocessor would be doing? Preprocessor takes these two inputs and produce the output, like replacing header file dependency programs, remove all comment lines, and replace macros, things like that. It pre-processes it and generates a actual source program. This complete source program is now you would be giving to the compiler. What compiler would be doing? Compiler takes the source program and translate into another intermediate program, for instance assembly program. So what assembler would be doing? Assembler takes the assembly language as an input, translate it into object. So the objective file which we see as an output of your compiler corresponding to your source C file. If we have a multiple C files, then you would be seeing multiple object files. All these objective files and a library objective file both together will be linked by linker, wherein you would be also using a static objective code. You might encounter a file .a files are the static object files, which will be also linked at the linker stage. Linker takes .a files, library files, and object files which are being generated by your compiler and assembler all together to generate a complete object code. Now this object code would be an input to your loader. What loader would be doing? Loader takes the complete object code and also shared object code that's called as .so files together and loads those into a memory, hardware memory, and the CPU executes that complete code on the hardware and produce the results as an output, isn't it? So this is a typical translation process of a computer programming in C world. Source code compilation. We have seen compilation is one of the conversion process while translating programming languages from source to executable file, isn't it? What we learned is compilation takes the source file and generate into intermediate programming languages. But what exactly it does for doing that? So what it does is it does a logical analysis, syntax analysis, semantics analysis, intermediate code generation, then after optimizing the code, generating the final code. The final code would be the intermediate programming is what you said before. Along with this, it also does two more things. Building a source table with all these symbols. You can call it as a symbol tables and error handlers. It captures all the errors, okay, within your source files. Procedure oriented programming. C program is basically a procedure oriented programming, which is a part of your programming paradigm. This is one of the approach. In procedure oriented program, you treated functions and data separately, procedures and data separately. If you have a large program, how you are going to solve the entire problem statement? Your problem statement is now divided into a small programs known as a functions. A function can also further subdivided into subfunctions. This approach is what we known as a top-down approach. Start from top and then keep drill down to lower functions. Procedure-oriented programming, more emphasis is on doing things, building an algorithms. Most of the functions uses a global data for sharing the data can be accessed freely from one function to another function. This is how you should be doing in procedure-oriented programming paradigm. Okay, C precisely we can call it as a procedure-oriented programming. Features of C programming language. C programming is a simple, powerful, syntax-based, case-sensitive, portability, platform-dependent, fast and efficient, compiler-based, modularity, structure-oriented, using for developing a databases. Applications of C programming. C program is used to develop an operating systems, design of a language compilers, assemblers, text editors, network drivers, databases like RDBMS, MySQL, language interpreters, utilities, development of video games, graphical user interfaces, browsers on internet, computational methods, graphical methods, cloud computing, distributed systems, server applications. C programming you can see in embedded system development. Embedded systems which are integrated into a larger system. C language is also used to write several computer language interpreters such as a Python interpreter, MATLAB interpreter. So like we have many applications which is based out of C programming language.
Thanks for watching. Please like, share, subscribe, click on the bell icon and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.